Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Now for this question, they want you to complete the diagram by drawing the diode symbols, right? So if you were to look at the clue here, they said that A is positive with respect to B. So if A is positive with respect to B, the current must flow this way. So how would I know which directions are these diodes? If the current flows this way, that means the current must come from here. If the current comes from here, means the current must come from here. So remember, where the current comes out from the full wave bridge rectifier, the two diodes must point there, must converge there. So the two diodes converging at this point will give you the current out here. Since these two diodes are pointing here, the other two must also point to the left, because if one point left, all of them must also point left. And for the next one, the symbol for the capacitor connected to provide smoothing. So you can draw the capacitor in parallel with the resistor. You can draw it here or outside, it doesn't matter, right? Anywhere, as long as it is in parallel. Now for this question, they want you to circle those diodes that are conducting, and R is positive with respect to P. So I label the positive here R and P is negative. So the current must come out from the positive. So it comes out from here, it cannot go this side because the diode is reverse biased, so it will flow here. So you can circle this is conducting. Once it reaches here, it cannot go up because it's reverse biased, so it's forced to flow down here, back to here. Now from here, it seemingly has two possible paths, either here or here, because both are forward biased. But remember, this is positive, and after passing through the resistor, there's a potential drop. That means this potential here is smaller than this point R. So current cannot flow from lower to higher potential, so it will flow to a lower potential here, which is connected to your negative. Alright, similarly, it cannot flow here because this is also before the resistor, because it is a higher potential, right? That's why the current cannot flow here, so the current will flow back here. So in other words, the very easy to remember is if one diode conducts, the one opposite to it will conduct, and the other two won't conduct. When this one conduct, this will also conduct, then these two won't conduct. The next one is to find the maximum PD between point Q and S. So the maximum PD between Q and S, if you notice that Q is before the load, S is after the load. So the maximum PD across the load is what we want, which is also the maximum PD across the supply. Because remember, when the current when the current passes through the diode is conducting, let's say from here to here, there's no potential drop. So when it flows here, there's a PD, then it flows through here, there's also no potential drop. In other words, this point has the same potential as your negative, and this point will have the same potential as your positive. So therefore, the maximum PD will be just the RMS voltage times √2, so 8.49. And the last one is just a qualitative question explaining, you need to explain how the capacitor is used to smooth the output. So you just have to copy this down, saying the capacitor must be connected in parallel with the load, and when the supply PD increases, the capacitor is charged. When the supply PD decreases, the capacitor discharges through the load, thereby maintaining a fairly constant PD. Now for this question, if they ask you for one advantage of full wave rectification compared with half wave rectification, it is that half wave rectification has a smaller average power, full wave rectification has a larger average power. So why is that so? Now if you remember, in half wave rectification, you're only going to get a voltage for half a cycle, so your power is also half a cycle. So what it looks like is, if the voltage versus time for half wave rectification is like this, the power versus time will also look like this. So for one cycle, which is from here, this area, So when you find the average of this first half of the cycle, you'll be half of the maximum, and then you got to add on with this second half of the cycle. So here the average is 0, here the average of this portion is half, so half plus 0 divided by 2 will get a quarter. So therefore the average power for half-wave rectification is a quarter of the maximum power. But if you look at full wave rectification, you are going to get something like this for your voltage versus time, or your power versus time. So therefore the average power will simply just be half of the maximum power. So full wave rectification will have a higher average power. That's all you need to say here. Full wave rectification has a higher average power. Right, the next one, they want you to draw on the graph, draw on the axis of figure 7.2, the graph that shows how the PD across diode A varies with time. So you must remember, A is only going to conduct for half a cycle. Now let's say it's conducting, there'll be no PD because it's ideal diode. Then it will have maximum PD when it's reverse biased, and then 0 PD again when it's fault biased, and so forth. But if you're going to draw for B, B is just the opposite. So where A was conducting, B wouldn't be conducting, so therefore it has maximum PD. And when A was not conducting, your B is conducting, so therefore there's no PD. But remember, whatever you have here must be opposite to here. In other words, if you start from 0 and go negative here, then this must be positive and a 0. But if you started positive and 0 here, then it'll be 0 and negative here. So this will be half the cycle, this will be half the cycle. As long as they complete each other, you're fine. And then the next one, they want you to draw the symbol of a capacitor to provide smoothing. So once again, you just draw it in parallel. Now, and then another one is what they give you was the PD against time after you put in the capacitor. So how the amount of smoothing may be increased? There are actually two ways. One is to increase the capacitance. The other one is to increase the resistance. But it is always much better to just increase the capacitance by adding another capacitor in parallel to your first capacitor. So that way you don't have to alter your existing circuit. All right, so don't talk about changing the resistance, because changing the resistance may mean that you're changing the application of your circuit. That means you're talking about different appliances. So that means for the same electrical appliance, you just want to increase smoothing. Easiest is no need to remove anything, just add another capacitor in parallel to the first capacitor. That's all you need to say here. And the second part of this question, just draw the increased smoothing. So don't forget, whenever it falls, it must touch the original curve first before it can actually go up. Then it falls, so you must go up to the highest point, and then it falls until it touches the original curve, and then goes up along the original curve to the highest point, then it falls. All right. For this question, you want to have 4 diodes to produce the polarity. So the polarity here is positive, and this is negative, so current must flow here. So if the current comes down here, current must come from here. So therefore, the 2 diodes must converge here. So these 2 diodes, make sure you point and converge here, meet here. So the other 2 diodes must also point to the right, since these 2 diodes are already pointing to the right. And for this question, if you want to draw the connections for supply and the loads, how do we know which connection is to which? Again, you must look at where the diodes converge. Can you see they all meet here? These two, they're all pointing up, and then they all meet here. So where the diodes converge, you must connect to the load. Opposite to it, also connected to the load. So these two will be connected to the load. The other 2 remaining junctions, you must connect to the supply. Now, if you don't want to draw like me this bump here, it's also okay. You can draw a straight line, but I just wanted to draw a bump here to emphasize that these 2 wires are not touching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help. Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.